Great. In the meantime, thank you all for coming. Obviously, most of you were probably here yesterday, heard the spiel. Much of what I base my opinions and my, consultation on is through the use of direct observation through the microscope. So again, I do a lot of direct microscopy, and then also I use a lot of meters that I just do testing for myself. So as a scientist, or a shade tree scientist, I call myself, I'm always trying to prove myself wrong. I think with science in general, we should always question it. I think we should always push it. And so with that, a lot of the preconceived notions that I've always, early on in my career, sort of the dogma of what I learned, that chemicals are bad and fertilizers are bad and we need to just get off of all that cold turkey and we need to go biological. Oftentimes I've proven that whole theory wrong again and again. Like yesterday, I think it was Nick that had the picture of the seed, the GMO seed with the colonization on that 48-hour shoot. I found the same thing. So I've looked at GMO, traded stacked seed before and taken the shoot out of the ground and done a wash. So what I do most of my collecting with out in the system is using these 50 ml test tubes, which is a really handy thing. In fact, most of my customers that I work with directly boots on the ground every year, I send a bag of 50 to their farm every year. So they have them in their glove box, they have them in their pickup, they always have them with them, and they're constantly collecting samples. They put them in the fridge. When I get there, we look at all kinds of stuff. But in the growing season, like from that first emergence, we're plucking things out of the soil, we're putting them in here, then we're basically filling it with distilled water, we're rinsing it off, and then we're doing what's called a wet mount and putting it on a slide, and we're just looking at what's there. And I can attest, because I've seen it, and we've seen it together with the producers, we have biological colonization definitely going on, GMO traded stacked seed. We even saw it where on corn, we had a nematicide treatment on the seed. We had beneficial nematodes on that root. So it was really cool because prior to that, I would have said, you need to do naked seed. I would have been real, uneducated and going under the assumption that, those asides that we have on our seed are going to kill our biology, right? So you need to go naked seed, which I'm still a big fan of, but that proved to me through direct observation, through the tool that is the microscope, because that's what a microscope is, it's just a tool. It showed me that we actually do have good biological colonization happening even on our genetically modified organisms that have tons of biocides painted onto the seed. So that was really cool, and that's been my career. I would say the most effective thing that I'm doing with growers and helping other growers do that want to learn the microscope and do their own microscopy is just doing that direct verification. So much of my advice, much of my insight, and I am not afraid to say I don't know, but much of my insight is through direct observation in the landscape. Like I was saying yesterday with Endless Beans, 2,4-D and Liberty, they went into the system. So old Zack would have said, oh, you've killed everything. And most people would think, oh, you've killed your microbiome that's in your soil that you've put in there. That wasn't the case at all. We saw teeming life in there. I haven't had the same sort of, revelation about certain things like glyphosate or dicamba yet. I see that as having a very detriment to the system, and I've looked at a lot of different growing systems that use those particular chemicals, and those do tend to kind of obliterate the system. So how I compare my analogy of what tillage, mold borer plowing does to a chemical through the microscope lens is a mold borer plow is going to create an earthquake. It's going to create an event, and it's going to take the organisms and it's going to bury them, and your bacteria are going to explode with life, and you see that bloom of bacteria when you go next to where the plow went through, where you didn't plow, the no-till, and you have a fungally dominated soil. You see this bacterial explosion 50x within 48 hours. It's clear to see. But still you see the fungi, still you see the protistas, still you see the nematodes. They're just rocked and shocked. That was an earthquake event. The tillage was an earthquake. A lot of chemicals from my vantage point, create a nuclear bomb. Like all of a sudden, the super kingdom of Protista appears to be gone. Your fungi appear to be almost completely gone as well, at least in active hyphal form. Your nematodes, where the hell did they go? They're gone. So that's how I would compare the two effects on the system. And so what I often say I'm helping farmers do, because I'm adapting with the farmer, I'm definitely not wanting them to quit anything cold turkey. I'm helping them manage disturbance. So if we have an event, if we have to go out there and spray something to control something, we better be putting something back. And our solution is quite simple. It's the microbes. It's that kind of fecal transplant I was talking about yesterday. And so not a lot of hands went up when I said the fecal transplant thing yesterday, but what that is when you use good feces from a good microbiome and you put it into a compromised microbiome and allow that microbiome to flourish in that compromised system. I've saved my own wife's life by doing that. She got a superbug in the hospital one time called Clostridium difficile, which is a very bad bacteria that basically destroys your colon, in addition to her Crohn's disease. And this standard Western medicine model is you need to go through 3 rounds of the worst antibiotics that we can throw at you before we will maybe consider you doing a fecal transplant, because we have all these medical journals that say it's 95+% effective at remediating this opportunistic pathogen that's destroying your system by doing a fecal transplant. I literally printed them off and took them into the hospital with me. And of course, who am I? I'm not wearing the coat. I was really talked down to, and I'm sure a lot of you have had those experiences in the system as well. So anyway, we did the course of action that the American GI Society at the time, this would have been 2021, said that we had to take. We went through 2 courses of terrible antibiotics, vancomycin and Cipro, I think were the 2. The side effects were absolutely terrible. My wife was in pain for approximately 6 months straight, level 10 pain. And when a woman says that she's been in level 10 pain, gentlemen, you know that that is seriously pain we could not handle. I am convinced that women have a much greater pain threshold than men, like through childbirth, through just their strength. And so I had to suffer with my wife for 6 months of this pain. Long story short, we got approved to do a fecal transplant. Who to be the donor? Me. So I went on this big juice fast, got really cleaned up my diet because I had about a 10-day window before the procedure. They did a whole bunch of testing on my poo. And they said, okay, green light, you can do it. So basically we went into the hospital, took my lunch bag of poo to them. They put them in their blender and they made this kind of wet concoction that they go in and basically they put you under into a colonoscopy kind of procedure, and they take the scope and router it up, and then like Ghostbusters 2 and the Statue of Liberty, they spray down the walls. And that's what they did. And so my wife, her procedure was at 1:30. She was out by 2. She was home by 3. And by 4 p.m., so only a little over 2 hours after the initial inoculation, she experienced her first pain-free symptom in 6 months. That works. Fecal transplants work. If any of you want advice or to talk about any of that stuff outside of this presentation today, I'm happy to share with you our story and just the power of that.
Now, can we buy that from you?
Well, yeah. So there are some serious mega donors out there. There's a tribe in Mexico, they're the Huarache tribe, I think, the runners, the marathon runners. They're big donors that make the prize fecal transplant stool because they've never had any pharmaceutical intervention and their diets are so clean. Seriously. But anyway, it worked. And how profound was it that after that whole shocking experience that we went through, did I make the correlation in my head that this is essentially what we're doing out into the landscape? We are creating these sort of indigenous microbiome transplants. We're raising them like we would a crop, and that's what we're putting back out into the system. I'm going to have to put my presentation, give me 30 seconds.
I can put it up for you if you can give it to me.
Oh gosh, I'll have to get it off my computer. I'm so sorry. Maybe,
Put it on this,
yeah.
or email it to me even, I got the internet here.
I won't have the videos, but that's okay. I can narrate them. And this is Dr. Rob.
Hello, everybody. Thanks for having me.
Technical difficulties. Why is this not?
Yeah, you got to stick with one operating system. They don't like communicating with one another.
Apparently not. Ah, here we go. Thank you all for your patience. Oh, yeah. Okay. So again, what I help farmers do is verify what's really there. And that's carrying around a lot of meters and machines with me. One thing I like to talk about is water quality. And what I have is a fluoride tester. I am a firm believer that fluoride, I'll give the American Dental Association the benefit of the doubt, is beneficial to our teeth. Does that mean we should be drinking it? I'm concerned that it's not. And there is an EPA limit to how much fluoride should be in our water. When I do my own testing with this, I find that that goes far above the limit every single time. And this is just me doing my own verifying. So I'm very particular about water. If there's fluoride in your municipal water, I would advise you to consider maybe not drinking it, maybe look into some sort of carbon filtration, bone char filtration, that sort of thing. But that's one kind of meter that has been very revelatory to me. Another meter that kind of goes outside of agriculture but more of our daily life now is an electrosmog meter. So I like to measure the EMFs, the radio frequencies that are in our atmosphere from all of our devices. And if I could impart one thing on you also right now, be careful carrying your phones on you. Because remember growing up, they said don't stand in front of your microwave while it's running. It's dangerous. It's very measurable, very measurable. Not only on RF frequencies, but in ELF, extra low frequencies, it sends this meter going crazy. When you hold this meter up to a phone that is just on, it's orders of magnitude 3 to 5 times higher. So we are being bathed in electromagnetic frequencies all the time. If you have a way to receive that feedback from the environment, from your different things, I'm just going to give this to you as a suggestion. I would consider your devices and your relationship to them and perhaps not have them necessarily on full blast. I would leave the Bluetooth turned off. That kind of sends it into a higher mode of frequency when your Bluetooth is from your phone is trying to constantly connect with something to connect to. Leave your Bluetooth off. If you were carrying your phone, I would honestly advise you to have it either in airplane mode or have it in like a Faraday bag, a blackout bag that cuts the electromagnetic frequencies that are coming off the phone in general. And I'm only basing it on the feedback that I've received by measuring it. That's it. That's it. So I'm not saying it because, I think it's bad. No, guys and ladies, this is seriously something we're bathing in this day and age. And your Wi-Fi router, keep it as far away from you as possible because that is just a solid, the amount of frequency that's coming off of that thing constantly would terrify you. Because when we look at, there's such a thing as building biology, that measures this sort of thing all the time, and their recommendations are anything, let's just say, without going into units or anything, but we want to be below 10. 10's the maximum of what human exposure should be. It pings this device at 1827. Phones, when you get like a call coming in, your phone pings at 1827. When I travel, I'll put this in my phone holder in my pickup because I'm super bored because I'm driving all over the freaking place, so what else am I going to do? So I'll just have this thing plugged in and turned on and just measure the ambient frequency of everywhere I'm going. And every about 45 seconds, your phone, 45 to 60 seconds, your phone's looking for its tower. So it's pulsing a frequency that is much higher than what is recommended for us to be exposed to. So anyway, if you have any questions about that afterward, we can talk about it, but it's just something that I like to measure and then I guess share that sort of information on with other people because it's something that we don't really think about. My kids will tell you I never stop. I'm constantly patrolling them about their phones, keeping them far away from themselves if you're not using it, keeping it in airplane mode when you do have to have it on you because of that excessive heat that's ultimately causing. And that excessive heat, they're finding, there's a correlation with bone density loss in people's hips now because carrying their phones in their pocket, God forbid, ladies that put them up here, hoofda. I would not have them up near your chest, your phones. So anyway, something to think about in our environment is the electrosmog. So anyway, okay, I talked about that yesterday. So again, I think everybody was here yesterday. We're trying to grow everything at once. We're trying to promote everything at once. We're trying to raise everything at once from our own system. So much of what I get to do is help farmers figure out what's best suited for their system for them to do this sort of microbe farming. How can we re-implement all of these microbiome creatures that are of our system indigenously there? How can we capture them and how can we recompose them to utilize them and put those back into our system? And so one of the easiest ways to do it is this is a Johnson-Su bioreactor method. Most of you are probably aware of this. If you're not, Johnson-Su bioreactors, YouTube, it will send you down a whole road of information and open source knowledge of how to make those bioreactors yourself. This is kind of an abridged version, which I'll go into in a minute, how this is different. But in a classic method, you're basically putting stuff together. You're putting 5 chimneys in place, bless you. You're putting 5 chimneys in place, you're putting your ingredients in there, and you're watering the heck out of it for about 12 to 16 months. What's been good is somehow my name's gotten out there, because again, I'm not advertising anywhere, that I can help people understand what they make. So I get a lot of people from the lower 48 that call me as a lab and say, look, I watched the videos, I've got the stuff, what do I do now? What do I even have? And so I've had the good fortune of looking at hundreds and hundreds of Johnson-Su bioreactors made by growers from seriously all 48 lower states that I could think of. I've seen them come from everywhere, and it's a really good method. If you just watch the videos or watch 2 videos of how to construct them and maintain them, it is a very good method at raising these microbes that we're trying to transplant back out into our system. So my version, and I'm not taking ownership of this, somebody else thought of it before me, but we got a lot of IBC totes on every farm I go to. And so why not recycle those and reutilize those? Ideally, we want a chemical-free tote, but beggars can't be choosers. We also build them in chemical totes as well. We just try to wash them out as best as we can. And really all we're doing is we're removing the top. Before we move the top, we punch a bunch of holes in it with a drill. Half-inch drill bit does the job. See you, Scott. And we kind of perforate the top. We then cut the top off with a Sawzall usually. We flip it upside down and we create sort of a lung on the bottom of the vessel. So then we can put our material in it and the material won't collapse and sit in water and putrefy. That's why we kind of keep it off the floor, because aerobic, oxygen, both of those words are absolutely paramount to what we're trying to do, because we're trying to grow aerobes. We're trying to farm aerobic organisms to put back out into an aerobic ecosystem, which are our soils. So anyway, you basically utilize the resources you have. In this particular context, this would have been outside of York, Nebraska. We had a lot of leaves, a lot of needle duff, things like that from his shelter belts. We also used corn stalks. We used a little bit of manure, and we used some old silage. And so basically we put the ingredients together, we put them inside the vessel, we tamp it down as we're building it to get as much material in there as possible. and then we fill the tote up. So close the valve first. Make sure your valves work before you even, sacrifice a tote to do this. But we close our valve, we fill it up completely with water, and we saturate it for about 2 to 4 hours. After that, we drain the water off, and we're off and running. And then we manage this by we go out and we temp it every day for about the first 2 weeks. What I usually want people to look for is that thermophilic gain. So we want to see the temperatures go up. We want to see the fever inside of that vessel go up, because we know things are actively working. And we know pathogens can also be sterilized by such an event. And so do a lot of monitoring. I have kind of a template that the farmer then takes on, especially if they're organically certified. They need to prove that they had the temperatures. But we verify that we did have that temperature increase. And then with this method, you don't have to turn it. That's the good news. And then you just allow it to slowly cool off and watch the temperature go down. One of my producers just at lunch sent me his 8 record sheets, because we built 8 piles 3 weeks ago, and his stuff is now officially, after 3 weeks, it's now under 90 degrees. So I've said, Jerry, great job. Let's go ahead and order your red wiggler worms, because after you get under what I usually think of as about 85 degrees Fahrenheit, you want to reintroduce red wiggler worms into that sort of a culture and allow them to keep breaking things down and providing a quality control for you. They continue to work. Let's see.
Lung at the bottom, you were saying there's a lung at the bottom.
That's just the gap that I've created using the old top of that. And I think this would be more conducive to your environment down here and in the Southwest, just because of your relative humidity in the atmosphere. This is going to hold moisture a lot better than the traditional way, which is to build it in a cage and line that cage with landscape fabric. I still have farmers that do that, and there's nothing wrong with that. That's the traditional way of doing the Dr. David Johnson Sue method, Sue his wife. But I really find the IBC tote does a great job for us. And you actually, what some guys do is they'll build a jig so they can put all their pipes in, because you want to be 15 inches off center. That's how you orient your pipes. But it kind of works out. We put our cage bars back on and we wire those pipes in place. And then typically when you're filling them, you'll want to have somebody holding them in place as you're putting your material in, tamping it down, and you basically have your hose hung over the side, filling it as you fill the bin with material. The best Johnson Sioux bioreactors that are being made by a commercial outfit in Des Moines, Iowa, called Midwest Soil Restore. We do a lot of testing for him. And the best recipe, and he's very open source about it, so I know he doesn't care about me sharing, but his best recipe is 50% straw, 40% hay, and 10% wood chips. No manure. There's no real strong nitrogen source in there at all. Traditional nitrogen source, yes?
When I was trying to build one of these, I had a hard time getting the raw material. And I've often wondered, and Chad Wall and I talked about this, could cotton burrs be a good material?
How big are cotton burrs?
Well, it's like,
Okay.
It's the byproduct.
It's a mulch.
Yeah,
Big quarter.
Okay.
yeah. I've often wondered, and plus you're getting there's microbes on that cotton burr.
Absolutely.
And so, to me, that would be for us out here. I don't have enough trees to get enough leaves. That was a struggle.
Yeah.
I mean, and then I tried to get wood chips, and I needed to find another grinder to grind those wood chips down even more. We just don't have. I don't grow corn, so
Yeah.
it's something. But you go to the gin and get a load of cotton burrs. Like for me, I'm an organic farmer, so I want organic cotton burrs. So I don't want any paraquat on it.
Yeah.
But anyways, it's just something. I've never had anybody say, yeah, that would work.
If for a green or for a brown?
It would be a brown ultimately. It'd be carbon. And it would take longer to break down, I think, by itself, but it's about maintaining the environment, which is a lot of moisture. Don't let it freeze. And as soon as you can get that environment, get the thermophilic, if there is a thermophilic event that happens with that recipe, get it past that till you get your worms in there, and just keep it wet. And also, for those of you who have barnyard cats, keep the cats out of it, because I'll tell you what, the times that I get bioreactors that have spirochetes and really kind of funky bacteria that you don't want to see, 9 times out of 10, it's the cat box. Their bioreactors become their cat box. I love cats, but seriously, consider that portion of where you place these piles and keeping it even, that's where you could use the landscape fabric. Just drape the landscape fabric over the top. Some producers leave their pipes in the whole time, the whole life of the pile. Other producers, they're making piles about every season, so they're constantly taking the pipes out. I think traditionally, from other people that do that, you can take the pipes out after about 48 hours. But, yes?
Do you have to have sunlight?
No, you don't need to have sunlight at all.
Done in a dark room.
Right. I've got some farmers that hang grow lights over there, and then they plant it with a cover crop and in the wintertime, and that actually stimulates a lot of biology. And their thought is they're actually waking up any mycorrhiza component that could be in that culture by doing so. And so then they take that material, they'll pull that kind of sod material out the top of it, they'll place it in a bucket, and they'll wash all that material off specifically for their seed treatment or their in-furrow. Yeah, so different things you can do to play with it. I really like the biodiversity that you see for people that do plant the top of it. Let's see.
Do the worms ever get their freedom?
Do they ever get their freedom? They do. They do a lot of moving, and I'll go into what you can do and actually turn these things into worm factories here in a minute. But moisture is key. I did an event with Dr. Johnson a few years ago, and his biggest question that he got asked over and over again was, can this freeze? And he would say, no, it can't freeze. I have these freeze all the time because people build 50 of these in their shelter belt and they leave them outside. That's okay. I mean, it's going to go through a freeze-thaw cycle. Your worms are probably going to suffer if they're already in there, but we just reintroduce the worms back once things thaw out. So I would say that's the biggest detriment, is things really do kind of lock up, obviously, when they freeze. But, the loss of your red wiggler worms would be the only thing prohibitive of allowing these vessels, these bioreactors, to freeze. But moisture is key. You want about 70% moisture on this. And some people, like the guy in Iowa that makes these commercially, he almost likes it at almost 80%. So basically you're taking the material, you're squeezing it, and it's running down the back of your hand. So then we use the valve to also control the environment. So we go out there, we temp it, we open the valve, we have something to collect the leachate in because we want to return that leachate right on the back, right on top of the pile again. That's not waste, that's just still food. And then after that, when we start adding water with our valve open, we're watering the top of it, we're showering the top. And my kind of benchmark of when we've maybe watered it enough by showering it this way is when we see a steady stream coming out of the valve. Then we close our valve, and then 2 days later, we come back and we do it all over again. After about the first 60 days, you can really start monitoring these things every 3 to 4 days, maybe even once a week too, once you kind of have a handle on the environment that it's in. Any other questions about this so far?
So do you need these to be in a well-ventilated area?
Not necessarily, no. I've got some people that literally have just put up kind of false, just some studs and hung some plastic in the back of their garage, and they have a little space heater in there just to house 2 or 3 of them. And yeah, that's dry country. I mean, that's like dry, western Nebraska would be the context there. So not as dry as down here, but moisture is going to be something to consider. In order for this to really work and break down quickly, you want to have moisture. Another thing that I'm seeing is from people that are doing this in successive years, that are using their last year's culture and basically bringing it, inoculating their new material with it year after year, the amount of time that it takes to finish and turn it into what I would say is a stable, usable humus culture that they could compost with, that window of time is shrinking. I had one guy this year, this would have been his 3rd year in a row, and all he's doing is taking a little bit of his last year's culture, and he just basically, he'll make a liquid out of it in a 5-gallon bucket, and he'll just kind of douse it on as he's building. He'll put it in a watering can actually, and he'll water it as he's layering his new piles. He had material that was what I would deem as was finished and extractable in about 3 months. So this is good news, because the biggest prohibitive thing about this method is the time that it takes.
Basically a year, right?
Typically, 12 to 16 months. And so when people send me samples, I want no information. I never ask them. I just, okay, send the sample, make sure you label it, or samples, because a lot of farmers are starting to play with different feedstocks, and I will tell you. And it's cool because I've been able to, with enough experience, correlate just by the maturity of the humus that I see, the actual aggregates in the microscope, the quality of them, the color of them. I've been able to get very close to kind of being able to determine its age by doing that. So that's kind of neat too. And I'm seeing people with things far less than 12 months that are very, very finished. This is another method. This would also be probably termed as the Dr. Elaine Ingham method. This was my original method of learning how to compost. This is the turning method of composting. This was in Texline, Texas. This would have been 5 years ago. And this is different in that we utilize a nitrogen source, a higher nitrogen source. So that typically can be manure. Ideally, non-GMO manure would be great, not always the most available thing. Seed is another thing. So like I said yesterday, beer mash is a wonderful thing. If you've got a microbrewery, it's nice and prehydrated. Oftentimes we just have seed. We have buckets of seed that are available on the farm, or chaff material. What I have the producer do ahead of time before I hit the ground and we build, I give them a big checklist, have all these things in place, basically pitchforks, pallets, very rudimentary things like that. I have them pre-soak the seed for 24 hours. So really wet the seed up. And then we use the seed as our high nitrogen source. So in the Johnson Soup bioreactor, anybody here ever heard of Jay Young? I'm joking. Everybody's heard Jay Young right now. Red Young Angus. Anyway, he does a lot of Johnson Soup bioreactors, and I've had the good pleasure of doing his testing for him for years now and helping him kind of troubleshoot what's the best recipe. His best one was 100% corn stover. So I didn't know anything about it, but when I gave him the reports, his best numbers, his most mature product was 100% corn stover. So in other words, it was 100% carbon. So the Johnson Soup method does give us, I think, a bigger margin to work with our materials where we could use, cotton?
Gin trash.
Yeah, gin trash. We could use something like that, and I think we have a real opportunity to recycle that, upcycle it into a humus again, given the right conditions. With this method, we want about 3 components, and that's a green, a brown, and a high nitrogen component. And then there's a ratio of the 3 that we put them together, and we create this event that creates these hot temperatures for approximately 15 days. If we use too much nitrogen, it could be for 20 days. We don't want to do that. We don't want to make more work for ourselves. Craig and Kendall in here know what that's about, because we built how many piles here? 8 piles, in 2021 at their farm. And some of those piles, the first couple, it was funny because they send me the monitoring sheets. I do like a 30-day coach after we put them together. So they'll take a picture of their monitoring sheets, they'll text it to me, I'll look at it, and then I'll kind of help them navigate the first 30 days. The first couple piles we built, which was, the demonstration piles very carefully, they got hot and then they, cooled off, turned them accordingly. The ones that the young bucks showed up and built afterward, after the demonstration, and did it really fast and really didn't keep their proportions in mind, you guys were turning those almost twice a day. They were so hot. So we are hitting temperatures of 130 to 160 degrees plus. I had one guy get up to 178 degrees up in South Dakota last March. I don't know how we did that, considering how cold it was that winter, but he had a pile that almost created a hay fire. If you get over 181 degrees, you do risk the combustion. So you have to be careful. There's a window we want to keep it in. And there's a whole turning process, which I teach as well. It's probably also on YouTube, so definitely do a deep dive on thermophilic composting on YouTube. But basically, we want to turn the inside out, so everything, again, hits that gut of the pile and gets cooked. And ideally, we want to be cooling off in about 21 days, starting to cool off.
So is it 12 to 16 months for the bioreactor versus 21 days for this?
60 days.
60 days?
So in 60 days, that's when whoever I go and build with, like directly, they send me a sample then, and as a part of kind of my feed, then I'll do an analysis then and kind of give them the green light or it needs more time. And I base that on the microbes that are present. I also base that on the humus substances that I also test, and looking at the maturity of the pile. This is just another neat picture. This was a big one we built on 2 pallets there in text line. And so finished, start to finish, that's going to be about 3/5 the size once it's broken down. I would say a pile that size would probably net him about 700 to 800 pounds, give or take. So the way we use material like that, though, another way to look at it is that's 700 to 800 acres worth of material, because we're washing that material because we're after the biology. We're after the microbiome that we grow carefully in a vessel like this, and then that's what we distribute back out into the landscape. So that's the biggest advantage of the thermophilic method. I build a lot of these in the off season because farmers are ready to get started by planting season, and so we'll do those first, and then everything else we have left over, our clean, kind of the cleanup, goes into a Johnson Sioux bioreactor. So we have our fast compost, and then we have our low and slow. So, and then the producer decides which one's right for them afterward. Typically, they go with the Johnson Sioux because this is a lot of work. This is like being married to a pile for about 3 weeks, because you're going out, you're temping it every day, you're giving it some water, and you're turning it accordingly. Ideally, only 5 times. Okay, so one thing I learned recently, and it was confirmed recently through Hugh Lovell, which is an author who's written several books, but the book Quantum Agriculture, he said this, that with thermophilic composting, you get a higher amount of actinobacteria, and I would say based on my observation over the years of looking at different composts, I would agree with that. And actinobacteria are very important in what they do for the ecosystem in terms of their rapid decomposition and what they actually exchange back to the rhizosphere of the plant. So this was just a funny one. So obviously farmers like to innovate, so we use all different kinds of ways to try to make it easier. And so I don't know what these cages were necessarily for, but we built it in this giant cage, and it was about this tall, and we used too much manure, and he put it's like a hay fan or something, or some type of a grain fan. He stuck that in the middle of it because it was getting too hot. So he needed to off-gas all of that respiration that the microbes were creating. So yeah, he put a fan actually physically down in the center of it just to help it cool off. So it takes some management. So this is just a kind of a nice example of one of the customers I work with that builds about 50 of these a year. So year 1, he'll build these in the fall. He'll put all of his raw ingredients in there. And so these are obviously sitting outside, and then in the springtime, he'll actually bring them all indoors and he'll consolidate them into 2. Actually, he'll build these in July, because by the spring or after planting, when he brings these inside, they've broken down enough that he can take 1 and put them into 2. And then he keeps those inside, and then that's what he extracts from. Context, that's in Gothenburg, Nebraska. So this was a video that probably won't play now, maybe. So this is a little bit of a cheat. I'm so sorry. Anyway, so if you got a feed mixer, that's a great way to mix up your materials. So this is kind of a cheat on livestock farms that we use. We put all of our materials into the feed mixer. We wet them up. We have an approximate weight that way, so we know approximately what our ratios are. And then we basically, 1 bucket at a time, pick it up, and then we set that bucket onto 2 IBC tote cages that we have ready to go, and we fill 2 cages at once. So 2 of us usually are pulling it in while 1 person's tamping it. And so that's an easy way to make a lot of these in a short amount of time. We did about a 10,000 pound batch out of this one. That filled 4 totes. No, that filled 4 totes, and then we had a big pile as well, which he wanted to try it with his bucket loader, so he used the rest of the material that way. Okay, so I've talked a little bit about this now, about how we use it. I mean, we're going to go spray 150 acres. Ideally, let's go weigh out 150 pounds of material. Wash it into as much water as you want. depending on the application. If it's a planting application, obviously our volumes are going to be lower. Or if we're doing an over-the-top foliar, more water the better, so we can really get it to penetrate into the system. But instead of playing a guessing game, or do I have enough microbes, and because that's early in my career, that's where it started. We always had to have the microscope on site, and we had to make sure to verify before we applied. I just kind of, I personally adapted this sort of easy 1 pound per acre. Let's just start with that. Like, I understand, you know, doing enough dilutions in a test tube and seeing what that would give us at 1 to 80 dilution. I just kind of saw that, okay, 1 pound should give us a pretty good microbial shot into the system. And that's kind of worked for us. And Dr. David Johnson says 2 pounds per acre of his material. So some farms I work with, they make enough pounds per acre. So they'll get a pound per acre, and they might split that into 3 or 4 applications. So they'll quarter their mass each time they weigh it out. So, and other farms, they'll put 2+ pounds out per application because they've made 50 of them and they have all the material in the world to use. So it's really up to you if you want to farm microbes, how much it is you want to make. And honestly, you could use it in every application, in every tank. If you want to put it in with your chemical, I'm not going to stand in your way and say don't do it. If you want to put it in with your commercial fertilizer, that's okay too, because we also have a lot of secondary metabolites. Yes?
So Zach, so if you put it into something like fertilizer or pesticides, how do you deal with the osmotic shock to microbes?
Oh, it's undoubtedly so. And so my only resolution for that is we're still hopefully getting some fulvic and humic acid component, the secondary digestate from the organisms, as a benefit. And because it's largely it's so much carbon that's in that, that's also helping buffer the fertilizer. I don't advocate putting your commercial fertilizer in with this, but some people have so much to use, they just say, why not? It costs me nothing to build, well, other than their time, which is worth everything. Yes, sir?
So you're making a solution?
Yeah.
Like a tea?
Yep, extract. Yep, so extract, and then we're just washing the solution, and then we bring our foods in later, which I'll talk about in a little bit.
So, sorry.
No, that's okay.
So, are you like treating seed? Or are you
Yep,
like
yep.
putting it in fertile?
So about 3 gallons of extract will treat a pro box. And that's about that 2 to 4 fluid ounces per 100 weight. So some people have commercial seed treaters, they put them in. Other people literally take a 3-gallon backpack sprayer and spray it in the auger as the seed's going up. And so very easy to do. And where I come in and verify is at planting season, I usually have them pull seeds that are treated and untreated, and they don't tell me which is which. And I pick it out 100% of the time because I see the fungal spores on the seed. So that's a great way to verify, again, that what we're doing is something.
Now, on your wet, do you do like Dr. Johnson and put a dripper on the top and then just let it put on timer? Or?
Some people do that for sure. So it just depends. Some people just have I usually mandate at least a sprinkler head on their hose that they can shower, because they don't want to just soak it in one space and let it all go down. They really want a nice consistent hydration when they water. But some people, absolutely, they have it all automated on timers. The company in Des Moines that makes them commercially, it's all automated, all of it.
So we've got a really hard time getting untreated seed, and most standard treatments have at least 2 or 3 fungicides on them. But even on that treated seed that you inoculate, you still see it's like you were saying earlier, you can't kill them all. You still see the fungal colony.
I stand corrected in yes. Yeah, I've totally seen the beneficial organisms we've seed treated, those treated seeds with, on the seed way after germination and colonized on the roots.
Is it better on untreated seeds than treated, or you see the same?
I don't know the answer to that. Yeah. I mean, ideally, I would like to take the treatment off of seeds because I'm a recovering eco-freak. I'd like to take that stuff out of the system as soon as we can, but that's trying to adapt with producers. Some of them just need that assurance, or the availability's not there and they're stuck with treated seed.
So you haven't seen a difference, or you do?
There undoubtedly is a difference, but what I can confirm is it's not killing everything beneficial. like, because I'm still seeing fungal colonization, I'm still seeing active fungi, I'm even still seeing nematodes where we have a nematicide on the seed where we should obliterate all nematodes, but perhaps the technology of that nematicide was so targeted that it only targeted the parasitic nematodes and not the beneficials. That's a complete hypothesis, but I mean, it was undoubtable. Like, you know, it stood me on my head once again that, okay, maybe this biology, maybe there is a more of a resilience than I have always been under the assumption there wasn't. Because they're such tiny little delicate creatures. Yes, Rob?
Fungi are just like your weeds. So if you're going out there with a fungicide for one organism or common pathogens on the seed, that they're completely unrelated to something like a mycorrhizal fungi. So just like your herbicides are going to be very selective, and your timing, your placement, your AI selection, same thing with this. So a lot of your fungicides on the treatment packages, you know, they're very targeted to things that are going to kill those seeds, like Fusarium, Pythium, Rhizoctonia, and they're not necessarily directly attacking things like Glomus and the different. This is the conversation with Dale last night.
Okay.
So there's still fungicide on your seed, but they're highly specific.
And because we're breeding cultures in magnitude of, I mean, and this is just based on one sort of DNA analysis, the biomakers analysis, you know, we're getting average farmers are getting 700 to 800 kinds of bacteria back, 200 to 300 kinds of fungi back with their analysis. A bug in the jug biological product out there, which I'm not trying to step on anybody's toes, everything has its purpose, but you might have 20 kinds of bacteria that live in that jug. So we're creating such a massive amount of diversity with this aerobic digestion method, which is what composting is, that we're really banking on that entourage effect. We're trying to put as many polycultures of organisms out into the soil into our monoculture of plants. Thusly, all 5 kingdoms at once. Okay, so a couple ideas. So producer in Nebraska, a different producer helped me understand this one. We were just playing around with different kind of ideas. We started actually top dressing his piles with food. So we started putting mulch, we started putting, leaf duff from, again, under the trees and the shelter belts, a little bit of hay. We started just feeding and putting an inch or 2 layer on the top of his piles just to see what would happen. Lo and behold, in 3 to 4 weeks, all that material gets digested. And who's all at the top who had done it? The worms. And so we started playing around with that. And so as a kind of a standard measure of doing our Johnson-Su bioreactors, we started mulching once a month. And then we starve them. We starve the surface for about a week after we come back that next month, allowing the worms to go back down into our pile, because we found when we would auger down to the bottom of the bioreactor and pull that material out, we still had a lot more solids. We still had a lot more mulch, carbon material. So we thought, well, why don't we starve the top now and let the worms go back down and do their job? And so we've played with that over time, because what you end up doing by doing this sort of top dressing method, you end up growing acres right inside of that vessel. You create so many worm casts on the top of the bioreactor that your material actually starts to go up again, and we just gain more pounds by doing so. Yes?
Question, so do you know why, or maybe other people, do you know why they pick red wigglers than anything else? And here's the question. There are a non-native species.
Right.
And they're also invasive.
Right.
Because I know, I mean, there's been interesting aspect that these red wigglers have moved across North America to such an extent that in some parts of Canada, there's no leaf litter on the soil floor anymore.
Okay.
Because and I'm just wondering, I mean, that's what a lot of people use. I'm wondering if anybody's ever looked at other worm species that are more native to being able to get the same process.
Diet is big, because red wigglers eat microbes and not detritus, versus like an earthworm that's just eating your plant material. Because earthworms have the same effect on the understory.
Right. Okay, but not as much. Because I know the group in Calgary that I work with, they documented that a lot of those deciduous forests in Canada now have no leaf cover at all, because of invasive species of worms from fishermen.
I've read that
Taking
too.
over. And I'm just wondering, do you know if these red wigglers, when you bring them on, because they lay eggs and everything else,
Uh-huh.
do they get into the fields and stay there?
They freeze, not, because I'm working more in the north.
So they freeze out?
Yeah, oh, absolutely. We do not find red wigglers in the system. Now, night crawlers, for sure.
Yeah, but not red wigglers.
Nope. And we know that also because when we do have to leave these out by necessity, we'll usually find a ball of, just kind of slime where they've all kind of gathered and then they've just, died, cooked. But anyway, another little tip, notice how on the top of he has drilled screws into that. So we did a little biomimicry there where we actually, by putting the top back on to the tote, we were getting a lot of condensation on the top, which was actually creating too much humidity inside the pile. So with biomimicry, we mimicked a cave and we put screws into it so that the water actually naturally dripped back down to the pile. And that actually worked for us. So there's so many ideas on the internet too. If you just search Johnson Su bioreactor on YouTube, there's going to be a wealth of knowledge and ideas, and it's all open source. And that, yes, sir.
So you're mulching in this because the pile is done, and you're trying to keep the life alive until you're ready to use it.
Right, and we want to grow worms because we don't want to buy them again. They're about $30 a pound, and depending on
Alive until you have your next.
right, and we want to grow more humus, which is what casts are. So that's where we're kind of capitalizing on what we already have in place, but then playing with it enough that we're looking at different strata of the pile and noticing what is the quality of the material that we're actually going to starve them out so they can go deeper, the worms can go back down, and they can continue to aerate and break things down, and then we pull them back up by enticing them with food. Yes, Dr. John.
Does anybody ever feed those wigglers to their chicken farms? Because that would be a good source of protein for them to recycle the stuff from the chicken food that way.
I hope so. I really do hope so because farmers I get to witness just they find the worms very valuable once they get them established. And they even sell them to other farms. Again, I like to go and work with groups of people to build guilds of language so they can support one another. And that's what's really cool about this is it's this like collective brain trust that we're all getting in on.
How many pounds of worms per one bioreactor?
I don't know if there is an approximate amount, but I usually promote a pound per bioreactor. Make it easy. Again, I just want things to be easy. So a pound per, and then if they do things right and they don't freeze, they never have to buy them again. And then they're just basically, have them put like a melon rind on the surface, that really gets them up, and then they'll just take a big shovel full, they'll throw it into the next pile after it's done heating.
We've set one up like this, a couple of small ones here in Lubbock to produce the worms to feed the animals at an elementary school that eat worms. You can get over a month, you get a couple 100 pounds of worms.
Oh yeah.
Easily and distribute them.
Definitely.
Yeah, so all the things, the lizards, everything else, the birds that ate worms, that's what we would just screen them out and collect them and leave some in there and feed the rest to the school's animals.
I love that.
Start a bait shop.
Yeah, right.
That's another reason they're using red wigglers. That's
Yeah,
how they
that's
get
exactly right.
their
Yes.
continuous feed, so they'll keep chasing the food and you can keep harvesting casting.
Yep.
So how do we do this on a commercial scale? You got over 1,000 acres plus. How do we wash that amount of material effectively to get it back out into the system? Well, on the market these days are commercial extractors. There's several of them that are out there. This is the one that I most commonly work with for my producers. My largest producer is 16,000 acres, so this is the one they use. They make about 150,000 gallons of extract a year. I appropriate any sort of operation that's over 1,000 acres to probably something more this scale. Something like this will wash approximately 250 pounds or 250 acres of material in about 45 minutes said and done, drained. And there is one of these in Muleshoe, if anybody wants to see it, talk to the geese Brex. But anyway, this is the tool for the trade. It makes it very easy. Trust me, I have done and seen so many DIY extractors, brewers over the years. There's a lot of ways that a person could do this on the cheap, even if it's just a cone bottom tank where you put the material in, you aerate it from the bottom, and then you let it settle out, and then you decant off the side your liquid solution. Obviously, filtration is key with making these biologicals because we do have bigger particulate matter that can clog nozzles, and I don't like those calls just as much as you don't like making those calls to me in the middle of the night. So I'm really conscious of our finished product. A product like this kind of makes it easy.
How much is that?
Well, new, a core bio extractor is $26,000. So he does have a leasing program that he started last year. I think it's $5K down. You get to use it for the season, and then if you want to buy it outright, you just take that $5K off of it, or you can return it to him. I've had one farmer return it because he was convinced he could make something better still, and that, all the power to him. But that's the tool for the trade. So how it's set up on operations, I have a couple different examples here. That's a scaffolding that's dangerous. I don't like this one because it actually sways as it's moving. They're going to improve that. That's a full tote that's sitting underneath it because that's where we drain our solids into. So there's a 3-inch plumbing in the very bottom of it. And basically, after you're done circulating it, you take a garden hose and you wash your solids out the bottom, and then you collect it in an IBC tote. This is a little more practical. Core Bio they are making platforms now, more like this one that you put a cut tote underneath, because all of those solids are also very valuable. So we actually, all of the things we extract, we wash off of it, all of that leftover residue that we filter out, we recycle that back into the pile, or what some producers do, like this operation here, which does a lot of gallons per year, they actually pipe their solids now out into a bunk, and they will have it pumped directly onto usually straw. They just set a whole bale of straw in there, so carbon, and then they just put all of those solids that they pump off, just pour it right on top of that, and then they lasagna build it, and then they end up with material at the end of the year that they pick up and they scatter it back into their main compost pile. Because when you're an operation this big, they actually make a windrow of compost that they make their material off of. Oh my gosh, how'd that happen? This is a little more practical size. So this is Midwest Soil Restore in Des Moines. He's the guy that makes the Johnson Su bioreactors. He just made this one to fit into an IBC tote. It's cheaper than the GOT, which the GOT brewer is the one that I've used for probably 12 years now, across the globe actually, which is another IBC tote version. But this one can do a large amount of compost. I think you could fit 200 pounds in his. The GOT, you're limited to about 40 pounds, so you can do more material and essentially make a concentrate this way. So you would put 200 pounds in there, 200 acres. You would make your concentrate, and then you would dilute it in your nurse trailer depending on the application.
How much is that?
It's not much, $2,900. And he's done, and so I did testing with them on this design too, as he was doing R&D this summer, and he sent me extracts that were 4 hours, 6 hours, 8 hours, 10, 11, 12, and 16 hours old, where he just let the whole thing circulate. And the one cool takeaway I found was that in 4 hours, we had no gains of fungal, we washed all of the fungal spores that we were really gonna get in that short amount of time. And so if the fungal spore component is what you're after, a short 4-hour cycle was all it took to wash all that material off. And then obviously, and especially after all of those samples settled out in the beakers, the longer that it extracted, the more solids we ended up washing off into the solution. So the longer, you're gonna get more, I would say, biology, you're gonna get more humus substances through the system that's gonna be then sprayed out into the system. But in the short amount of time, it was neat to see that, wow, we loosened up all of our fungal spores right away. That's the name of the game with the Johnson Su bioreactor, and Dr. Johnson will tell you that himself. He is primarily focused on fungal spores. He says that, and this is his words, A properly finished, mature bioreactor will only have fungal spores, and you won't see any of the other organisms because they've all basically gone into dormancy. I like to see everybody. That's my own personal take because I want everybody to come to the party. So I want the protista, I want the nematodes, I want everything else. So that he would deem that probably as less mature than what his finished product should be. But for those of you who are making Johnson Su bioreactors, they're 12 plus months old. Chances are they have consumed, the fungi specifically have consumed everything, and then they've gone into sort of a dormant spore form. And oftentimes Johnson Su's that I get will be just predominantly fungal spores. So if that's the case, if that's what you have and that's what you're going to use, it doesn't take but just a couple hours of aeration before you loosen those spores off, and then you can distribute those back out into the system. So the things to look for in the season, I like to go and I like to pull up the last year's residue and just see how the decomposition of it's going. So pretty easy one to see. See how alive the surface of your soil is by looking at how well it's breaking down. Ideally, you want to see some fungal activity. Those look like white threads to the naked eye. Those are called mycelium. And that's essentially telling us that that component that's embedded in our soil is digesting our residue from the previous year. Other things that I take out into the landscape with me, obviously that's more of an analog refractometer, thermometer, of course, measuring soil temperatures, obviously a spade, penetrometer up there on the third picture up at the top, looking at soil compaction, measuring the differences in compaction of the soil. This is really good to use all these metrics when you're trying different things. So it's cool being able to work with farmers who are, unbeknownst to them, they're actually being scientists. They have a question and they're seeking an answer through an experimentation. So that's where we employ meters and different sort of feedback loops to understand what are the differences we're seeing beyond just what the yield monitor says at the end of the year. So in season, we're looking at soil compaction, looking at different treatments, seeing if we soften our soil more by doing that. And then on the right, we have a digital refractometer. I use both because with the digital, I get an approximate number, and with the analog, I get that line of demarcation inside of the refractometer, which is either cloudy or it's solid, and that tells you your mineral density of the plant. Gives you an idea of what the mineral, the total dissolved solids of your plant is. If it's a hard line, that means it's pretty mineral deficient, and if it's a fuzzy line, that means it's very mineral rich. And that I'm plagiarizing from Dr. Christine Jones, who I was with at a field thing this last summer, because I've heard it both ways for so many years. That was her determination of using the line of that refractometer to give us an idea of what is the nutrient content of our plant at that stage. So for producers in here, obviously you're used to these screens. These are the screens that it takes to run biology in your system. Ideally, I'd like you to be at a 30 because that's bigger, but 50 is typically the ones we have on planters. That's typically on that commercial extractor. That's a 50 mesh screen that the material sits in. So yeah, big nozzles. Yes?
I've always wondered, like, so say you do this, you go out there and do a phone or broadcast spray, how much does a drought affect those microbes? Are they there? But if we go through these long periods like we had out here, and they start to die when there's no moisture in the soil?
Undoubtedly so. I mean, they're so dependent on moisture. They're so dependent on temperature as well. I like to do dusk or dawn applications. Stay out of the middle of the day, the UVs of the sun. That's kind of rule number one. Rule number two is if you can get it subsoil, that's the best. That's where the seed slice is the most opportune place. Or if you do like a side dress, or you have drop nozzles that you can lay it right on the row, that's second best. But yeah, that's a very important component to the environment, the abiotic stress on the system. So the opportunity is to get it right on the seed. So think plant seed and microbes simultaneously.
Well, that's been my approach. Is let's put it on the seed, give it the best opportunity, because I guess I'm a little jaded after these last 3 years of droughts, where it's just like, man, you do all this stuff and then it ends up raining and it gets above average temperature. You just, it makes it a little bit more of a challenge, I think, out here in the drought area.
Oh, undoubtedly so. Yes.
I would rather put it on the seed, contamination as possible. That's what we've been doing, but, you know, been hoping the best, that it doesn't rain again. But anyways, it's kind of frustrating.
Well, that's what one of my producers has done to address that very thing with the Don Duo interseeder. So he actually, with his saddle tanks, he has his biology in one saddle tank, and he has his foods, like his amino acids, his fish, his minerals in the other. And he actually combines them right out of the meter tube, and he puts it 7 inches on either side of the road. He usually does that on the summer equinox. He does that for his corn and his beans. And I love it because he's making kind of a syrup clear out on, you know, that far away from the plant. And we've verified it's definitely there, you know, 24 hours later when we go out and pull samples. And then as those plant roots hit it, then they just explode. And we see actually a really dramatic effect on nitrogen. Like, we don't see deficiency so much in this system because he's using biostimulants in a way that is supportive of the plant and the microbes, and he's kind of growing them together. So that was a cool rig that he set up to do that and avoid UV exposure altogether.
Is it better to have the biology slightly off the seed line versus just right on the seed?
I don't know. I think whatever works best for you is, you know, ideal. But I mean, I don't know if there. Yes, Dr. John might know.
So, yeah, so the literature from the 70s would indicate the microbes, the seed we'll see when it first germinates, are not necessarily the ones they need. You need ones that are different types. Because part of the problem with fungi is like plant. What is the size seed difference between Palmer amaranth and cotton?
Right.
In terms of the size of that seed. Is cotton a weed? No, because it's seed type that it produces. A lot of fungi, which are weedy, produce a ton of seeds or a ton of spores, but they don't do much, but they just produce a ton of spores. So when you look for them, you're going to see only the weedy species. So all the literature that I've read over the decades is when the seeds are first germinating, they need to be able to germinate in an environment in which if they come in contact with a lot of fungi initially, they're not large enough to interact with it sufficiently. So you have to give them time to grow a root system. So putting that root system away initially, let them grow to it, is probably the best thing. Because then there's the right amount of exudates. The balance between what's going on above ground and below ground is in par with how to stabilize. Because it's like an infant. If you dump a large amount of probiotics into a baby that doesn't have the right system, it's not going to do well.
Right.
It has to be able to manage, because the microbes are going to signal we want stuff. And the plant's not large enough to do that yet. So, you know, so there's always been this effort over the years. And I've worked with, some of you may know, I've known Bobby McMichael from the USDA. We spent a lot of time on seed coats and dressings and everything else. All the stuff that we've done and other people have done in the USDA, the spores you put on seed coats are the phytoplankton fungi that are on the leaf surfaces, and that they're not the ones that are in the rhizosphere. The stuff that's on decomposed plant material when it comes in are not the same fungi that benefit the roots. Because they're in two different systems.
Saprophytes.
They're both saprophytes, but they're different saprophytes. So the microbes we have in our skin are not the microbes that are in our gut. So the stuff that's above ground and coming into the ground may be there for a month, and then they all go away. And the stuff that's in the soil, because it's a different type of microbial response environment, they're the ones that take over. And they're the ones, so it goes back to what Johnson was talking about the number of spores. The longer you leave it, the more you get the soil microbes rather than the normal plant above plant microbes.
Okay, like the residue.
They have to change.
Okay.
It's time for them to change to be able to. So you're right. So leaving that stuff longer actually is more of a benefit.
Yeah, absolutely. And some people oftentimes I'm asked, well, when does it go bad? And I mean, in text line specifically, where I've gone for 4 of the last year straight, our original material that's, you know, aged under their trees in tote sacks, essentially, is their best in terms of microbial diversity, fungal spore counts, everything. It is absolutely astonishing what is still alive in there. So I don't know what the answer is anymore because Elaine used to say 18 months.
Yeah.
You need to use it.
I mean, that's like, I think it was Dale was showing pictures of mushrooms in the field.
Mm-hmm.
Mushrooms don't produce any spores in compost.
No.
And in fact, a lot of fungi don't sporulate at all, the beneficial ones. They just grow as mycelium.
Yeah.
And so you want to add those back. So the longer you leave it, the more the complex carbons are taken over, the simple sugars are gone, the weedy species are gone, and yeah, you have a much better product. Year and a half.
Thanks for clearing that up, though, about planting. I'm going to have to keep that in mind this year.
Yeah, because we've known for a while that if you add a lot of mycorrhizal spores on the seed at planting and they develop, they don't necessarily grow well because the carbon demand of the fungus is too high for the plant at that point.
So
you have to be able to grow into it.
So it harms the plant and the fungi together then ultimately. It stunts its growth. Okay.
What was the analogy with the baby?
Oh, the baby's like the probiotics. If you need probiotics, you can't get the same probiotics to a baby because you may cause a permanent damage because their gut microbe is just not mature enough to be able to deal with it. Plant seeds are the same way. It takes a while to build up a root system, but particularly it takes enough to get the cotyledons in the first leaf to produce enough photosynthetic product to get down below ground and deal and find the fungi that need to be there and the bacteria.
Okay. Huh. Thank you, Dr. John.
The natural systems balance all that out, but that's also why a lot of plants produce a lot of seeds because it doesn't always work well.
Mm-hmm. So drawing to a close, here's talking about DIY. This is a DIY compost extractor that is kind of modeled after the Hiawassee extractor. So what the producer essentially has done is he's created an auger himself, and then he dumps his material in through that box and then augers it, and then there's water that actually shoots over the material as it's squeezing the extract, squeezing the juice out of it, which he collects then in that tote, and that's how he makes his extract. He likes to make a lot of machinery. This is his homemade inner row weed flamer. He's got a lot of crazy ideas. He's outside of Ames. And this was an interesting one that I did actually just before I came here for a farmer. So has anybody in here heard of the Green Lightning product yet? Okay, so it's basically this nitrogen that you're charging into the water with electricity, making your own nitrogen. Some of the tests that some of us have done so far, it's a very trace amount of nitrates that we measure. Talking with, what's his name from Hugoton who spoke yesterday? Nick, talking to Nick yesterday, he tested the stuff and he got a lot of nitrites, so we're not sure if like storage played, because Rob tested it and found no nitrates, but nitrites, but nitrates. Nick found only nitrites and not nitrates. I tested it, found that it's about a 3-4 pH, so it's acidic. Its conductivity is around 2 millisiemens, so it's got some ions in it as well. But what the farmer wanted to do, and what a lot of farmers ask me is can I use this with my biology? Does it have a detrimental effect? And so I created a baseline with just water, and then I did different dilutions of the Green Lightning up to a full extract made with Green Lightning. And this is basically, I wish I had a pointer, but this is basically what the numbers looked like of what it did to our biology. So in terms of the top with our baseline, we can see across the board, we had much greater diversity, much greater biomass of fungi. We had a much higher, narrower fungal to bacterial ratio because we are trying to promote fungi. We do want to have more of a balance of fungi to bacteria when it comes to biomass. Nematodes, we had a diversity of nematodes in our product as well. We had more fungal spores. We obviously, the flagellates and amoeba and ciliates, those are your protozoans. Those are your things that eat the things. They're some of your nutrient cyclers or your kind of third rung of the food chain. We obviously had higher biomasses across the board. And as we added more of this Green Lightning product, we saw a negative effect on the biodiversity of our material. So this has been only one experiment. Hopefully I get to do a lot more. I would say my advice to the producer was I would feel comfortable with you using up to 25% if you really want to, because now he has the unit himself and he's making it 24/7. He spent a lot of money on it because they're expensive. And he saw this and said, I'm going to save it entirely for foliar and leave it away from my extracts altogether. So that's been, clarified with him already. But as we increased in strength of the nitrogen product, our protozoa really took the biggest hit. They just disappeared. And in fact, once we got past 50%, the only protozoa I could find went into a cyst form. So their motility, they completely shut down, and then they went into like a preservation mode. So was it due to the acidity of the product? Was it due to the nitrates of the product, which is very small? It was like 100 parts per million, so it's not very high. I'm not sure what it was due to, but all I can deliver back to him is what happened. And that's through the counting and measuring I do with the direct microscopy. So that's kind of cool to finally have an insight into its effect on the biology. I do think it's a cool product, the green lightning technology. We'll see where it goes. Has anybody purchased one of them yet? The devices? Okay. Well, not to talk you out of it, and I'm on camera, and Green Lightning's going to see this, and I'm not suicidal. I love my life, and Green Lightning, I'm all for you guys. But this is just all I'm able to see. That's about all I have for my show. Questions?
Zack, I have a question.
Yes, sir.
I recently heard a podcast, and they were interviewing the wife, and she had IMOS, Indigenous Microorganism Solution.
Okay.
They're up in North Dakota, I believe, and they were going out to a place on their farm that had never been disturbed, digging up some soil and feeding that soil for a week or 10 days, and then putting it through a brewer.
Mm-hmm.
And they're talking about making the brewer out of common stuff you get at the hardware store for about $150.
Yep.
I watched their YouTube, and it was over an hour long.
Mm-hmm.
Didn't really tell you anything in that. They want to sell you a 3-hour, 4-part video for $500.
Okay.
And then they want to sell you the food to feed the soil before you make it. That's as far as I got with it.
Okay.
But the idea of the concept was, okay, you've already got the indigenous biology on your place. Mm-hmm. Let's grow that.
Yep.
So I just wondered if you had any thoughts about
I've heard of people using that. I haven't heard any results or people. I've heard of some people in that outfit doing that method. I try to just adapt that sort of mindset with the way I train people how to grow, and we do the same thing. We go out into let's find the biggest tree we can find in your township, whether it be your property or just that general region. Let's go pull some of that soil up, and let's introduce that into the landscape. Let's take some of your field soil. I kind of go around and help them collect different ecosystems from throughout just their farm and incorporate that into their system in hopes that we can capture that indigenous microbial population as well. Now there is like the Korean natural farming method, which is very much about that, KNF. You can go on YouTube and see a lot of that stuff. The American ambassador is named Chris Trump, easy to remember. He goes through all the different preparations. I think it's still kind of open source and shows you how to do that kind of cultivation of your indigenous microbes from a different methodology. There's Jadam, which is another method of natural sort of organism cultivation that you can buy a book, and it shows you a lot of recipes to do, where you're putting like a colander of rice in the soil underneath a big tree like that, leaving it for a week or two in order to encourage the microbes into that. Then you take that, combine it with equal amounts of sugar, and there's all these different preps. But I worked with the largest KNF farm in the country in 2021 in Iowa, and he went full KNF, drank the Kool-Aid, did away with the entire commercial, his farming knowledge, did away with it all, bless his heart. He's commercial farm. He's gone back to the conventional methods a lot because step by step. Like when I used to work with golf courses, I learned from my first golf course that gave me all 18 greens after that, every other golf course was, let's start with half of the putting green, because there was a huge learning curve with turf. When you're trying to apply an ecological model to an unecological system like a golf green, it was a lot of growing pains because they don't like worm castings on their greens. Any other questions? Yes?
So some of the producers you're working with, it looks like they've fully integrated this with their annual systems where they get the extracts and they put them out on their fields to get the biology. What isn't the overall goal eventually that you don't need to pull those extracts, that they'll already be in your soil?
So I've always been under the assumption that the answer is no, that we should always want to plant these organisms with our seed, because it's that whole approach of growing the kingdoms to, like, let's promote total fertility. Let's see what that looks like. And it's kind of it's kind of a recycling of our system. It's kind of regenerative in the whole practice itself. But this summer in Iowa, where we didn't apply any biology and he only did his foods, we went out into the fields and still saw teeming biology from 2023 and 2022. That stood me on my head.
So maybe eventually, once you get a good baseline out there, maybe you only have to do it every couple years or so.
Yep, and I mean, we have to verify that somehow, whether that be through us or a PLFA, which is another biological metric that's more objective. I'm all for it. We need to ask it of the system. But yeah, absolutely. I mean, that'd be great to make our lives easier, because it takes a lot of work to do this stuff.
So once you have this extract,
Mm-hmm.
you have to be really careful to keep it out of UV sunlight. Your pump pressure, can that destroy the organisms? How long can it be stored? And is it just like kind of a ticking deal? Shelf life?
So pump pressure is low PSI. 80 to 100 is probably the very maximum, but most guys run it more like sub 40. You know, they keep it very low. Diaphragm pumps are great for organism transfer, as far as what I've seen. Even centrifugal pumps are great for organism transfer. And that's me literally collecting what comes out of the applicator. As far as storage goes, in a black poly tank for storage purposes is best, because you are reducing UV exposure that way. In that sort of scenario, having some sort of way to aerate it or circulate it until you get it all working also kind of helps, I think, keep the aerobic nature of it. But there are companies out there that I do testing with that they have sort of proprietary things that they're doing to suspend the organisms. I know using humic acid. I don't know what else, because they don't share that stuff with me, but I have stuff on my shelf at the lab that's 16 months old and it's aerobic and it's got a lid on it and everything. I know pH buffering could do some of that. If you lower the pH low enough, I'd say sub 6, I want to say, you're going to suspend bacterial growth, which that's what you risk by taking an extract, shutting its air supply off, is it's going to run out of oxygen. And your facultative anaerobes, hopefully, that are there, that's what's going to wake up, and after they've consumed all the oxygen in that vessel. So storage-wise, what I tell guys is you can make the extract, don't introduce any foods to it, and obviously through kind of mindful storage, keeping it out of the sun would be the main one. You have about a week to 2 week shelf life as is. If you can at least aerate it once a day. And we'll look at dissolved oxygen as well, just to kind of make sure we still have enough oxygen day after day after day to kind of monitor that. Now in July and August, when we get really hot, that might go to a couple days. But as long as we leave the biology and the food separate, we really do have a margin to work with, versus a tea where we've put them together right away and we've exploded their populations. That's where the margin of use is very, very short. So, and I see that because, like, oftentimes just for fun, when I stay overnight on a farm, we plant it up until, into the evening, and then we go back out the next morning and look at the bottom of the tank at what we had left over. Not only will the biology be completely different, it will have gone completely bacterial. We've alkalized 1.5 points of pH. We've somehow reduced in the ions, the electrical conductivity of that solution. It's like a completely different mix than we were applying the night before. And that'd be in a matter of 8 to 10 hours, granted in the heat of the summer. So that's why I advocate keeping the two things separate, and we activate those extracts into the applicator tank per batch. So if we break down, we may only lose a tank versus our nurse trailer. Yes, Dr. John.
So one of the things, someone was asking about how long will those microbes last. In the ecological literature, people have done transplants of soil monoliths from one landscape to the next. So for example, they've taken prairie grasses and put them into cornfields to see how long. It's about 3 to 5 years.
Wow.
And the reason they've changed is because the environmental constraints are not the same as what was in that grassland versus within the agricultural land. The little bit that I know, been familiar, what's in the compost in terms of environmental conditions is not what they see in the field. It's a completely different temperature,
Right.
range, moisture, everything else. So they're going to change in response to that conditions that you run in your field. And you can't do anything about it because they're responding to it. So the comment to the question is, do you have to keep adding the biological to the effect? The answer is yes.
Yes.
Because they're responding to the conditions that are in that field, and each year is slightly different, but it's not what they've seen in the compost over
Right.
the year. And you're selecting for them.
Right.
But when you put them in the field, that's not what they see. That's why if you log a forest, you go back and plant mycorrhizal species on trees, you can't use them from the forest. You have to use them from an area that had no trees to begin with, because they're the ones that can adapt to that environment.
I see.
So that's why the environment really is the driver of all this, in terms of temperature and moisture as to what they see.
And this isn't a one and done thing. I mean, it's definitely, it takes repeated applications.
It takes repeated applications, and I think somebody mentioned it too. You have to get them to start working with the environment you have. If you modify your environment to be more conducive, less variable, you're going to see a much different response than if you just allow the system to do what it needs to do.
Right. Yep. A lot of people are after the coveted, 1-to-1 or above fungal to bacterial ratio, which I think is just a theory. I mean, I'm not sure if that's like necessarily the proven, but it's something we track. And I say about 3 years. So the farm I worked with in Texline, we did it in just a little bit under 3 years. We went fungally dominant, and he's an organic person, so we had tillage that we were still competing with, but we were able to do it in 3 years. But that was 3 to 4 applications every year.
So do you see a difference with respect to the soil type, like a sandy loam versus a clay loam?
Absolutely. I mean, microscopically, it's...
Well, what about responses to the treatments?
Yeah, I see a better response in sandy, because they're more well-drained soils. I see more of an establishment of your higher order organisms, your protozoan especially, in the more well-drained, lower CEC soils than I do in a tight clay. Yep, for sure. Good question.
Even though there's not as much
Organic matter? Right. I mean, they really do seem to cling onto the plant. I work in more sands, I would say, for the most part, than I do clay soils, just being in that kind of vein between here and North Dakota, in dryland country especially. And I noticed that in those soils, the rhizosheathing is more pronounced initially. Like right away, we see that association right away. It's just like the microbes know where the organic matter's at because it's growing right next to them, and they really do cling in that sort of case versus having 4 or 5% organic matter hanging out everywhere else, almost like distracting them to go to these other places. But not to complicate you all, this is something to consider, look into, take forward. If you have any questions, come grab a card from me. I've got brochures for those extractors. I've got merch on the back table. Reach out. I'll help in any way that I can. So thank you all very much.